Hey, thank you for the follow, Judge Judy Slayer. Thank you, thank you, thank you. I'll be live in just a moment. And by just a moment, let's go with right now. Hey, hello. All right. Let's go back to some top interview questions on LeetCode, starting with the easy collection. All right, best time to sell stock. That's such a hard problem. All right, contains duplicates. Given an integer array nums, return true if any value appears at least twice in the array, and return false if every element is distinct. Okay. This should be easy enough to do. I think that we're going to want to use a hash to keep track of the numbers that we've seen. That does give us O of n space complexity, but that's not the end of the world, I don't think. Maybe there's ways you could do it in an O of 1 space complexity, but I'm not going to confuse myself with that before you even have any working solution. So we probably want a hash, right, to keep track of things, right? Const scene equals an empty hash. And then, let's see, return false if every element is distinct. So const r dupes equals false. Return r dupes. Probably do is dupes. Okay, and then we want to iterate across. For let I equal 0. What? Oopsie daisy. Let I equal 0 while I is less than nums dot length. I plus plus. Okay, so if nums of I is in scene, else if nums of I is in scene, then r dupes equals true, and we can break the loop. Else scene at nums of I equals true. You can put anything in there. We'll just do true as a flag. Okay, so the idea is we initiate a hash, we set up r dupes to false, we iterate across the array. If we see a repeat value in the hash, we set r dupes to true. And then we break out of the loop. Otherwise, we continue keeping notes of the values we've seen. That should do it. I think that should do it. Let's try. Runtime error. Oh, whoops. Yeah, duh. Let r dupes, not const r dupes. My bad. True. All right, let's try submitting it. Hey, there we go. It got accepted. Nice. All right, cool. That one was really easy. No, they're not all that easy. Some, like, best time to sell it, best time to buy and sell stock too. I'm still not sure how to do that one. Given a single number, given a non-empty array of integers, nums, every element appears twice except for one. Find the single one. You must implement a solution with a linear runtime complexity and only use constant extra space. Okay. Okay, so it's has to have linear runtime complexity and only constant extra space. Constant extra space. Okay. Well, how are some ways that I would solve it without those? And then maybe we can start with that, and that can give us part way to the ideal solution. So you could count them in hashes. I've seen two. Element appears twice, except for one which only appears once. How might we flag that? You could use... you can't really use an array, though. A second array. I was going to say that you could have, like, an array of array elements. An array of arrays. Thought of two solutions that could use O of n extra space. But neither of those are valid. Man, this no extra space is really tough. Spend another like 10 minutes trying to grok this, and if we can't grok it, then we'll go take a look at the solution. And see if we can empty array of integers nums. Every element appears twice except for one. Find a single one. Hey, happy Monday, Nikki. Hell yeah, well, you've come to the right place. Lots of input in the solution when you run down on constant extra space. Man, this one. Not guaranteed to be adjacent. All right. Bitwise X. Oh my gosh, this is a bitwise XOR. Well, no wonder I had no idea how to do it. I am not at all familiar with bitwise operations. XOR. Bitwise XOR? I don't know how I feel about this. So it required XOR. Yeah, so hash table, list operations. were the two that I had in mind. Math. If we take XOR of 0 and some bit, it will return that bit. If we take XOR of the two same bits, it will return 0. So we can XOR all bits together to find the unique number. If we take XOR of 0 and some bit, it will return that bit. If we take XOR of the two same bits, it will return 0. Okay. So it's essentially taking a function that when you smash two of the same numbers into each other, they become 0. And when you smash one number and a 0 together, they become that number. So by performing that operation over and over and over, you can smash all of the duplicates together. And they'll all come out to 0, and then all those zeros come out to 0. And then you have 0 and the one unique number, which comes out to the one unique number. Well, I did not know about that XOR bit manipulation could do that. Intersection of two arrays. Given two integer arrays, nums1 and nums2, return an array of their intersection. Each element in the result must appear as many times as it shows in both arrays, and you may return the results in any order. Sweet. Okay, so we could iterate across both arrays, store their values in hash tables, and then we could iterate across one of the hash tables. Grabbing the elements for both of them. Yeah, let's do that. Okay. Okay. Const nums1 nums 2r's equals that. Const make hash equals making a helper function just to convert both of these arrays into hashes that we can work with more easily. Snack after this toy problem. If hash at r of I else okay. So we have a basic function for turning these things into hashes. Okay. After we make those two hashes, there we go. That's what I was looking for. For const property in object. For const key in nums 1r's. Okay. So we need to if R1 and R2, if they both exist, constant shortest R const R to append equals R1 dot length is R2 dot length. If R1's length is longer, then we append R2. Okay, I think this will work. I need to debug this, so let's go use the debugger. Intersection of two arrays. There's a runtime error in the solution? What? Okay. Can't just go over 1. Wait, yes, you can go over 1. Returns a new array. I need to append. I think we can do this. We can do let. All right, this one worked. Oh, they just wanted the 2? Each element must be unique. Okay, well that's easy enough. Intersection dot push. This is a slightly different problem than the other one I looked at. But we got it right. Nice. Hell yeah. That was a nice, tricky, challenging little problem, but we got it done. All right, I'm gonna grab a snack. I'll be right back. She has 2 snacks, but she doesn't know what to do. She's struggling to pick between them. Coughed a little. Just wanted to make sure she was okay. All right. We've done some array ones. Let's do some string ones. Write a function that reverses a string. This one's easy. This should do it. Oh, this is a really quick solve. No more snacks, Abby. You just had some snacks. Abby's begging for some more treats. What? We can see in the debugger that it's getting reversed. What the hell? That's really bizarre. Oh, I know what's happening. It's checking it in place. That's what's happening. If we're gonna do this. Figured it out one way. We need to figure it out another way. extra space for another array. You must do this by modifying the input array in place with O of 1 extra memory. I've already done this one. Hey, look at that. Already done it. Try some linked list problems. List, remove the nth node from the end of the list, return its head. Could you do this in one pass? Could you? Alright, this one's going to be trickier. First, we need to count the length of the linked list. if target equals current, I don't think this is going to work off the bat, but let's see. Oh, we're only off by 1. Ooh, I'm struggling to remove the final node. one. I'm a little burnt out on toy problems. Been a little over an hour of them now, which makes sense. Toy problems are quite draining. Bone up on linked lists. In this card, we're going to introduce another data structure, linked list. Similar to the array, the linked list is also a linear data structure. Here is an example. As you can see, each element in the linked list is actually a separate object, while all the objects are linked together by the reference field in each element. There are two types of linked lists, singly linked lists and doubly linked lists. The example above is a singly linked list, and here is an example of a doubly linked list. Okay. Singly linked list. Each node in a singly linked list contains not only the values, but also a reference field to link to the next node. By this way, the singly linked list organizes all the nodes in a sequence. Here's an example of a singly linked list. The blue arrow shows how nodes in a singly linked list are combined. In most cases, we will use the head node, the first node, to represent the whole list. To add a new value after a given node previous, we should initialize the new node current with the given value, link the next field of the current to previous nodes next, unlike an array, we don't need to move all the elements past the inserted element. Therefore, you can insert a new node into a linked list in O of 1 time complexity, which is very efficient. Insert a new value of 9 after the second node 6. We will first initialize a new node with value 9, then link node 9 to node 15, finally link node 6 to node 9. After insertion, our linked list will look like this. As we know, we use the head node head to represent the whole list, so it is essential to update head when adding a new node at the beginning of the list. To delete an existing node cur from the singly linked list, we can do it in 2 steps. Find current's previous node previous and its next node next. Link the previous to the next node next. Let's Try to delete 6 nodes from the singly linked list above. Delete node 6 from the singly linked list above. So maybe I should be looking for the previous node, not the current node. If we want to delete the first node, the strategy will be a little different. As we mentioned before, we use the head node head to represent a linked list. We simply assign the head to our... If you want to delete a final node, you go to the previous node, and instead of setting it to next, you just set it to null. Design a linked list. Add a head, add a tail. Let's design this linked list. Whew. Let's take a break before we do that, though. All right, what's a good break? I struggle to get breaks that actually help me relax on stream, because I just feel on all the time. Yeah, I think that works well. Let's play some games. Let's try it. Let's do some magic. Taking a quick little Magic the Gathering break. Alright, we'll keep this hand. This hand works. First, we want to play out the Shambling Ghast. mana drop. That is very bad. Very, very bad. Very, very bad. Oof, still just mana jammed. Another Blade Historian. God damn. Will he block? No block. Alright, he's gonna try and kill me this turn. Let's see if he can do it. The fact that I might actually win this game is looking pretty nice. Enough to get me. Oh my god, he had just lethal. Wow, 2 Rimrock Knights. Wait, we're not dead yet. Woo! There we go. That was a really close match. Goddamn. treasure token. Kill this robber of the rich. Showdown of the skulls out here. So many goblins. Nice, he made a mistake. All right. Oh, Orcus. That's what I needed. I really needed Orcus, actually. Nice. We're in some pretty good shape. Yes, the game did just snarl at us. that, man. Goodness, what the hell is happening? Where the hell is Shadow? Shadow, are you all right? I think this person's AFK and is about to lose the game. Well, that was an easy win. A very boring win, but an easy win. All right, let's exit the game. My brain does not want to focus and do this work right now. I'm gonna take care of some chores that are not this, because I'm struggling focusing on this. I want to get more productive stuff done this morning, but I'm struggling to focus on this right now. Got a good hour and a half in, which is not bad at all, actually. I'll have to get in some more time later today, though. But first, I gotta run to the grocery store and pick up some prescriptions and do stuff like that. Okay. I'm going to call our stream for the morning. I'll be back this afternoon, likely twice this afternoon, potentially with a bit more streamed software engineering content, and I will also be back doing some gaming this afternoon. So I'll see all of you then. Nikki, thanks for coming out. Judge Judy Slayer, thanks for the follow. Everyone, I hope you've had an excellent morning, and I will see you this afternoon.